So in this video, we're going to be on page 6, learning how to set up a proportion and use the proportion to be making predictions, generalizations, and conversions. Now I want to remind you guys that on page 5, you were just solving the proportions, which is just a skill for how to find the unknown. And what we're doing now on this page is we're actually reading through some scenarios to set up a proportion, which we will then solve using either method 1 or method 2. All right? So at the top here, now that we're comfortable with solving the proportions by either finding a scale factor or cross-multiplying and dividing, we are going to be writing proportions to do 3 things. We're going to make predictions. We're also going to make generalizations, just kind of assumptions about certain scenarios. And we're also going to be converting different units of measurement. What I mean by some conversions are things like inches to feet, when we're taking inches on a map and comparing it to feet in real life. We're going to look at a problem where we compare how much we weigh on the moon compared to how much we weigh here on Earth because of the impact of gravity. We're also going to be doing things like converting different units of money from different countries from around the world. So what we're going to be doing is essentially asking ourselves one question. What am I comparing in the problem? First thing we're going to do then is write what we're comparing with words. All right? I'm going to go through and explain what this process looks like down here with a word problem. Let me first just finish going through the process. After you ask yourself what it is you're comparing, you're going to write it down with words first. Then you're going to write down that ratio with numbers, and that'll all be given to you in the word problem. Then you're going to be setting it equal to what you're trying to either predict or convert or make a generalization about. I want to remind you guys that when you're solving, you can either solve using method 1, which is to identify a scale factor, or you can solve by method 2, which is to cross multiply and divide. And so that's what we have up here in the process, that you're solving with either method. And then of course you have to write your answer with correct units. So let's dive on in and take a look at this pizza problem. So Papa's Pizza claims that 2 pizzas will feed 7 people. If there are 20 people invited to Tim's birthday party, how many pizzas should be ordered in order to feed all of his guests plus Tim himself? All right? So the first thing we're going to do is ask ourselves, what are we comparing? We're comparing the number of pizzas to how many people it will feed. So right here with words, we've written the verbal model with words. We're comparing pizzas to people. Now the first ratio that we've been given in the problem is that 2 pizzas will feed 7 people. So we can use that to figure out how many pizzas here, unknown, will feed 21 people. Yes, there are 20 people going to the party, but Tim is also going to be there, so there's 21 total people who need to eat. Now, this is the proportion that we have set up, okay? And so the steps are, first, write down what you're comparing with words. Then you're going to set up a proportion, and now you can use either method to solve. The first thing that most of you are going to spot is that there's a scale factor here in the denominator of 3. And so then 2 times 3, we're going to get 6 pizzas. You could also cross multiply. So for method 2, if you multiply here 7 times x, it should equal whatever 2 times 21 is. Well, 2 times 21 is 42. And when I divide by the 7 to cancel it out, we still get 6 pizzas. The last step is to make sure you label the answer and box it. And now we're done with number 1. Now we're going to take a look at this next problem about Tim getting a model of an F-16 Fighting Falcon for his birthday. So we can see here in the problem that the scale of the model is that 1 inch of the model will represent 3.3 feet of the actual plane in real life. If the wingspan on the model is 10 inches, what is the actual wingspan of the jet in feet? So the wingspan, y'all, it's the thing that goes from this edge to this edge. And what we're saying is that on the model, from here to here is 10 inches, and we want to know the actual length from there to there on the actual Falcon. So we are converting in this problem. And what we're going to do is we're going to write up what we're comparing first. We're comparing inches to feet, and we've now written it in words. We've been given that 1 inch will represent 3.3 feet in real life, and we're going to use that now to convert the 10 inches that the model actually is to how many feet it is in real life. Now, this proportion has been set up, and we can identify the scale factor of 10. 1 times 10 is 10, so 3.3 times 10 would be 33. Or, if you don't want to worry about the scale factor method, you can cross multiply and divide. And so here we're going to multiply 1 times x, and that's 1x, and 3.3 times 10 is 33, and then obviously 1x is just x, so we get that the actual wingspan would be 33 feet across in real life. Now down below what I have is, it's the same problem about Tim and a birthday present for the F-16 Fighting Falcon, and it's actually still the same scale of 1 inch represents 3.3 feet in real life. This time though, I want to point out that I'm giving you the actual wingspan of the jet this time, and I want to know the wingspan of the model. So now the location of our unknown changes. We were still comparing inches to feet. We're still using that 1 inch represents 3.3 feet. But this time what we don't know is in the numerator, we don't know the number of inches, and we do know the denominator is 33 feet. If you compare back to this problem, we were given the model inches, which is in the numerator, and our unknown is now in the denominator. So you just got to be careful and read the problem and figure out, where is our unknown? Is it in the numerator with what you've set to the numerator, or is it in the denominator? If we go back up to the pizza problem real quick, the unknown was the number of pizzas that should have been ordered, and that was in the numerator up here. Now down here, if we were given that the actual wingspan of the jet is 33 feet and we're trying to find the inches, we can cross multiply and divide. And so once again, if you cross multiply, you're going to get 1 times 33 is 33, and then just divide it by 3.3. So 33, when I divide it now by this 3.3, we get 10 inches. Okay? So it just depends on what you're given, and that's where you're going to put in the number, and then you're going to try to figure out what's unknown, and then that is where the x goes. Now let's flip over to the next page, 7. At the beginning of the basketball season, the Warriors won 11 games and lost 7. So right there, the ratio that we're given is the games won compared to the games lost. So from this problem right here, we're given wins to losses, and we're comparing 11 wins to 7 losses. If this rate continues, how many games will they win in a normal 80-game season? So we actually don't care about wins compared to losses. We care about wins compared to the total. So this is a part to total comparison, not the part to part. So if we add the 11 and 7 games, we can see that they've played 18 games total, and now we're ready to compare the part to the whole, that they've won 11 games out of the 18 total, and we can use that to predict how many wins they'll have out of an 80-game season. Now personally, I can't see a scale factor from 18 to 80, so for this one, I'm just going to cross multiply and divide. When I multiply 11 times 80, it's 880, and when you multiply 18 times x, you get 18x. Now you're going to divide both sides by the 18 for it to cancel out, and in the calculator, you're going to get 48.88888. Let's make sure you see that in the calculator, the 880 games divided by 18. So these 8s repeat, which means if we're having a conversation about how many games we actually expect the Warriors to win, it'd be somewhere between 48 or 49 games. And technically, since this rounds up, we would say we expect them to win 49 out of the 80 games. Now, one thing I do want to point out is that so far, if they've won 11 out of 18, they have won about 61% of their games. So 49 out of the 80 should be the same percentage. Now 49, because it's rounded out of the 80, you're going to see that it's slightly off, but it's still about 61% of the games. For the next problem about King's Dominion, the waiting time to ride a roller coaster is 18 minutes when 120 people are in line. So that's the first thing that we're given. We're comparing how long you're going to have to wait when we're given a certain number of people in line. So we're comparing the wait time to the number of people who are in line, And we're told that 18 minutes is the wait time if 120 people are in line. We're going to use that to predict how long someone would have to wait in line if there's 280 total people in line. So this is a part to a whole, and once again we can just cross multiply and divide. When you multiply 18 times 280, you get 5,040, and when you multiply 120 times x, you get 120x. Then you're going to divide both sides by the 120 for it to cancel out, and we're going to get that the wait time here would be 42 minutes. Now, recipe problems are really popular in this unit because it's very easy to say, okay, so here's a single recipe, and now if you're going to be having a party, what do you need to do to all of the ingredients if there's going to be more people? Well, obviously, the more people who come to your party, the more ingredients you're going to need because you want to make more of whatever it is in the recipe. So in this situation, we're told that a recipe for chocolate chip cookies calls for 3/4 cups of brown sugar for every 3.5 cups of flour. My first recommendation is going to be to take this 3/4 cups of brown sugar and convert it to a decimal, 0.75. Now let's take this 3.5 cups of flour and make it a decimal, 3.5. And we're comparing the amount of brown sugar needed to the amount of flour. Then we're going to use that to set up the proportion. And now what we're going to do is read that it's telling us if 2.5 cups of brown sugar are used, and brown sugar is in the numerator, so there's the 2 1/4, which is 2.25, we're going to use that to figure out how much flour is needed. So you can see that we're obviously using more brown sugar if it originally only called for 3/4 cups, and now it's calling for 2 1/4 cups. So we're going to need more flour, and let's figure out how much more flour we're going to need. So you can just cross multiply and divide. In your calculator, the 2.25 times 3.5 is 7.875. And then over here, you've got 0.75x. Now you're just going to divide both sides by that coefficient to get 10.5. Now because the word problem has fractions, I'm going to recommend that we put a fraction in our answer. And we can now safely say that 2 1/4 cups of brown sugar would need 10.5 cups of flour for the recipe. All right. One final problem here on page 7 before we have another couple on page 8. So this is an example of how to convert from one unit of measurement to another with money. Karen is planning a trip to Europe, and she needs to exchange her US dollars to euros. Now, with the exchange rate, 1 euro is $1.13 here in the United States. So we want to know how many euros Karen is going to get if she plans to exchange 2,500 US dollars. So once again, what are we comparing? We're comparing euros to US dollars, and we're given the ratio right here that 1 euro represents 1.13 US dollars. We don't know how many euros she's going to get if she's exchanging 2,500 US dollars. Notice US dollars is represented here in the denominator, and there is the 2,500 US dollars in the denominator. At this point, the only thing we have left is to cross multiply and divide. 1 times 2,500 is, of course, 2,500. And then here we've got 1.13x. When you divide by 1.13, you're going to get 2,212.39 euros. So 2,500 US dollars is only worth just over 2,200 euros. All right, now let's flip over to page 8. We've got one more problem up here. And this one should hopefully clear up the difference between part-to-part ratios and then part-to-whole ratios, okay? A TV station, XYZ, is using a new strategy by airing only sitcoms and reality shows. Popularity polls indicate that the ratio of sitcoms to reality shows is 2 to 3. Folks, this is a part-to-part ratio, where we're comparing the number of sitcom shows to reality shows, and for every 2 sitcoms, there are 3 reality shows that are going to air on TV. A sitcom is something like Seinfeld or Friends or Modern Family. A reality show would be something like Keeping Up with the Kardashians. And we can see here if we add them up, there'd be 5 total shows. Now, in the spring lineup, there's going to be 20 total shows. So how many of them are reality shows? So I want to remind you guys that in the reality shows, we were given that there are 3 reality shows when there are 5 total shows. 3 out of the 5 were reality. So 3 out of my 5 total were reality, and I can use that to now predict how many out of the total 20 lineup are going to be reality. Now for me, this is an easy scale factor to identify. 5 times 4 is 20. So 3 times 4 is how I'm getting that there's going to be 12 reality shows. So sometimes the word problem is going to provide the part-to-part ratio. It did it here, and it also did it here in the Warriors basketball example. And it might provide the part-to-part where you need to add it up, and now you're going to use the part-to-whole ratio. So back for this problem, part-to-part was 2 to 3. That meant 3 out of the 5 total shows were reality. And that allows us to predict that 12 out of the 20 shows would be reality shows. Another way to check is that if there's 2 sitcoms and 3 realities, again, 3 out of the 5 is 60%. 60% of the shows are reality shows. So now let's divide the 12 by the 20 total, and boom, we can see right there that 60% are reality shows. Now I want you to pause the video, and I want you to try the next 3 problems, and then when you hit play, the answers will be exposed and you'll have a chance to check. So pause and work on the next 3, and then you'll hit play. All right, there are the 3 answers. It's 240 minutes, 16 boys in the class, and right here when we cross multiply and divide, we're going to get 23064 divided by the 19.22, and it looks like 23,064 pesos is worth 1,200 US dollars. So for the last one, it looks like Luigi exchanged 1,200 US dollars. And that concludes this video. Thank you.